Welcome to Study Loop.
So now we'll work on problem 106 from chapter 17. This question here has two parts. So first they're telling us that there's a solution of iron and magnesium of different concentrations. And so it's telling us that if potassium carbonate is used to selectively precipitate one of the cations while leaving the other cation in solution, which cation precipitates first? So we answer this question first by looking at the KSPs. So our KSP for iron carbonate, which is one of the possible precipitates, is equal to 3.07 times 10 to the minus 11. Now for magnesium carbonate, the KSP we can get from the table in our book is 6.82 times 10 to the minus 6. So since this one here has the lower KSP, it will precipitate first. So the next question the next part of this question is what's the minimum concentration of potassium carbonate to trigger this precipitation? So for that, we need to set up our Q. So when precipitation begins, Q is equal to KSP, and KSP, since we have a 1-to-1 ratio of anion to cation, is just going to be equal to the concentrations times each other. So we're given the concentration of iron as being 0.02 molar, and the concentration of carbonate is what we're solving for. So if we solve for concentration of carbonate by dividing KSP by carbonate, by 0.02 by iron concentration, we get 1.40 times 10 to the minus 9 at this concentration of carbonate or potassium carbonate. If we're including the whole molecule, precipitation will begin. Now, for the second part, they're asking us what is the concentration of magnesium, what is the concentration of iron when magnesium starts to precipitate? So after we've increased the concentration of carbonate enough so that magnesium starts to precipitate, what's the concentration of iron left in solution? So what we need to do is we need to calculate the concentration of carbonate as our first step when Mg magnesium carbonate starts to precipitate. So we set Q equal to KSP, which for magnesium carbonate is 6.82 times 10 to the minus 6, which we saw from our first part here. And this is equal to the concentration of magnesium times what we're solving for, CO3 2 minus. So carbonate concentration is 4.87 times 10 to the minus 4 molar. So what we need now to do is to calculate iron concentration at this concentration of carbonate. So we set Q is equal to KSP, this time the KSP for iron carbonate. And now we're solving this time for iron concentration times what we solve for here, which is 4.87 times 10 to the minus 4. And then we solve for iron by dividing both sides by 4.87 times 10 to the minus 4. And that's equal to 6.30 times 10 to the minus 8.